In late 2004, inside the massive industrial complex in Aachen, Germany, the fires were permanently extinguished. For 50 years, the Philips Valvo picture tube plant had been a beating heart of European consumer electronics. It was a place of extreme heat and heavy chemistry, melting tons of glass daily to press the thick screens that illuminated living rooms across the continent. But now the lines halted. Nearly 1,000 specialized workers were sent home. This was not an isolated event. Soon the same industrial silence would fall over Thomson's sprawling assembly halls in France and the state-built Pokolor foundries in Poland. The paradox was that demand for televisions had never been higher. In the electronics shops of Berlin and Paris, historic European brand names still glowed brightly on the shelves. The consumer saw no interruption. The logo remained exactly the same. But behind the glass, the manufacturing system had been entirely dismantled. The real story of the European television is not about corporate bankruptcy or trademark licensing. It is the story of how an entire continent built heavy industrial foundries to master the physics of glass, only to be erased by a technology they could not manufacture. Every week, we tell the stories of the television brands, factories, screens, shops, repair benches, and living rooms that once defined how Europe watched the world, and what remained when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific necessity on a muddy construction site in western France in 1957. Before the television became a global commodity, it was a heavy, dangerous, and fragile piece of physics. In the years following the Second World War, as broadcasting began to expand across the continent, European companies realized that the television set could not be easily imported. The heart of the machine was the cathode ray tube, a massive glass envelope containing a highly pressurized vacuum. It was incredibly dense at the front to prevent implosion, and delicate at the neck where the electron guns were housed. Shipping these heavy glass tubes across oceans was an economic nightmare. The transport costs alone destroyed any profit margin, and the breakage rates were unacceptable. Because of this physical reality, a television had to be built relatively close to the living room, where it would eventually sit. To sell televisions to the French, Thomson had to build a factory in France. In 1957, they broke ground on a massive site in Ankers. It was designed not just as a workshop, but as an industrial city. In Germany, Philips heavily expanded its Valvo component plants in Aachen to ensure a steady local supply of picture tubes for the booming West German market. These factories were marvels of mid-century manufacturing. They required a completely different workforce than early radio assembly. Television chassis ran at lethal voltages. Winding the copper deflection yokes required extreme precision. The wooden cabinets were often milled and veneered on site, requiring massive carpentry divisions operating alongside electronics engineers. When a consumer bought a television in the 1960s, they were physically connected to an industrial town just a few hundred kilometers away. The brand was trusted because the factory was visible. The television set solved the problem of domestic entertainment, and the physical weight of the product protected European factories from long-distance competitors. But the black and white era was merely a rehearsal. The television was about to become infinitely more complex, and the factories were about to grow to a scale no one had anticipated. The transition to color was coming, and with it, the need for chemical laboratories and massive glass foundries that would define an era of industrial glory. In late August 1967, at the International Radio and Television Exhibition in West Berlin, Vice Chancellor Willy Brandt pressed a large red button, officially launching color television broadcasting in West Germany. 2 months later, the French government inaugurated its own color service. This transition from black and white to color did not simply change what audiences saw on their screens. It fundamentally altered the industrial architecture of Europe. Color television required a manufacturing breakthrough so physically demanding and so chemically complex that it transformed regional assembly workshops into some of the most advanced heavy industrial foundries on the planet. To understand why the factories had to change, one must look inside the new object itself. A color cathode ray tube was not just a larger light bulb, it was a lethal, precision-engineered vacuum chamber. Inside the narrow neck of the glass tube, 3 separate electron guns now had to fire distinct beams. These beams traveled through a highly pressurized vacuum toward the front glass. Just millimeters behind the screen sat a metal shadow mask, punctured by hundreds of thousands of microscopic holes. The three beams had to pass through these exact holes to strike precise microscopic dots of red, green, and blue phosphors painted on the inside of the glass. If the alignment was off by a fraction of a millimeter, the picture was ruined. Furthermore, to pull those electron beams across the heavy glass screen, the television chassis had to generate immense magnetic fields and lethal electrical power, often exceeding 25,000 volts. The copper deflection yokes wrapped around the neck of the tube had to be wound with absolute mathematical perfection. Because of this physical reality, European television brands could no longer operate as simple carpentry and soldering sheds. They had to master chemistry, metallurgy, and the brutal physics of molten glass. In West Germany, Philips poured massive capital into its Volvo component division in Aachen, expanding the site into a multi-hectare complex. This was not a cleanroom laboratory. It was a heavy foundry. The air smelled of ozone, hot flux, and industrial solvents. Massive furnaces melted specialized glass continuously, pressing the thick front panels that would protect families from the vacuum implosion risk. Workers wore heavy protective gear to handle the tubes, carefully banding them with steel tension rings. In France, the Thomson assembly plant in Angers expanded to cover nearly 90,000 square meters of floor space. It was no longer just assembling parts. It was orchestrating a massive, vertically integrated supply chain that consumed raw copper, plastics, and glass by the trainload. The requirement for heavy industrial infrastructure even crossed the Iron Curtain. By the late 1970s, the Polish government recognized that securing technological independence for the socialist bloc required mastering color glass. In 1979, utilizing technology licensed from Western companies like Thomson and RCA, Poland established the massive Unitropol color plant in Piaseczno. It was a staggering state investment, a sprawling complex designed to ensure the domestic market did not have to rely entirely on imported Western tubes. For the European consumer in the 1970s, a color television was an enormous financial commitment. The retail price often equaled 2 or 3 months of an average worker's salary. Because of this high cost, the customer did not buy a television from a generic supermarket. They walked into a specialist electronics retailer. The shop owner would demonstrate the brilliance of the PAL or CCAM color standards, explicitly connecting the high price tag to the engineering reputation of the domestic factory that built it. And if the complex machine failed, the retail system was backed by a highly localized repair network. A local technician, often the same person who sold the set, would arrive at the family home. Armed with a manufacturer-issued service manual, the technician would carefully remove the wooden back panel, discharge the high-voltage flyback transformer, locate a blown resistor or failing capacitor on the heavy chassis, and solder in a replacement. The television was a repairable household investment, intimately supported by the local economy. This localized system created a massive barrier against foreign competition. Japanese manufacturers were already producing highly reliable, innovative televisions, but the physical weight of large color sets protected the European factories. A 26-inch color cathode ray tube was incredibly heavy and fragile. Shipping containers full of heavy empty glass vacuums across the ocean was a logistical nightmare. The transport costs effectively acted as a protective tariff. To sell a large television in Europe, a company largely had to build it in Europe. The sheer physical difficulty of manufacturing color glass had given companies like Philips, Thomson, and Grundig an impenetrable moat. They became national champions, employing tens of thousands of workers in highly specialized industrial towns. But this glorious breakthrough contained a hidden structural weakness. The massive glass furnaces in Aachen and Piaseczno could never be turned off. If the molten glass cooled, it would solidify and destroy the furnace. The foundries required continuous, massive production volumes to justify their fixed costs. The entire European television industry had built an empire upon the continuous pressing of heavy glass. The factories had mastered the physics of color, and the sheer weight of their product had built an impenetrable fortress around the domestic market. But that same massive infrastructure was quietly trapping the industry inside a heavy technology that would one day become a fatal liability. By the mid-1980s, the European television factory had reached an unprecedented scale, becoming the undisputed anchor of the continent's consumer electronics industry. The sheer physical footprint required to build color cathode ray tubes had transformed regional companies into industrial empires. Inside the Thomson plant at Angers in western France, the sensory experience of manufacturing was overwhelming. The factory floor spanned nearly 90,000 square meters, a sprawling indoor city operating in continuous shifts around the clock. The air hummed with the deafening rhythm of mechanical presses and the sharp smell of molten solder and hot flux. Conveyor belts stretching for kilometers carried bare, heavy chassis boards through automated wave soldering machines, where a perfectly timed crest of liquid metal secured thousands of electronic components in a matter of seconds. Mechanical arms, guided by highly trained workers, swung the massive steel-banded glass picture tubes into place. In West Germany, Grundig's massive facilities in Nuremberg operated on a similar, staggering scale, employing tens of thousands of workers across its supply chain. Philips, orchestrating a pan-European network from the Netherlands, fed its assembly lines with tubes pressed in the fiery furnaces of the Volvo plant in Aachen. These were vertically integrated behemoths, designing the chassis, pressing the glass, and milling the wooden cabinets in-house. But the European manufacturing system was not a monolith, and its glory was not limited to the French and German megacorporations. In Italy, the industry perfected a completely different architectural model. Instead of relying on state-backed conglomerates, the Italian market was dominated by fiercely independent, highly efficient regional factories. In the town of Abbiategrasso near Milan, the Mivar factory operated under the strict, uncompromising control of its founder, Carlo Vender. Mivar did not attempt to build a sprawling global empire or invest billions in semiconductor research. Instead, it operated on hyper-efficient, strict cost control regional manufacturing. The Mivar factory turned the CRT television into an accessible, practically designed piece of domestic furniture, capturing massive shares of the Italian market by eliminating waste on the assembly line while maintaining rigorous build quality. Even across the Iron Curtain, the physical mandate of heavy glass created massive industrial centers. In Poland, the Unitra Polkolor plant in Piaseczno reached its peak output in the 1980s. Operating as a state enterprise, it became a vital supplier of color picture tubes for the Eastern Bloc. It was a massive industrial ecosystem that supported thousands of Polish engineers, glassmakers, and assembly workers, ensuring that the socialist living room was illuminated by domestically produced technology rather than imported Western screens. Regardless of whether a factory operated under French state ambition, German engineering precision, Italian cost efficiency, or Polish central planning, they all shared one defining characteristic. They were cities of employment. These massive facilities dictated the economic rhythm of their surrounding regions. They supported thousands of secondary businesses, from the logging companies providing timber for the cabinets to the regional chemical suppliers mixing the phosphors. This heavy industrial system extended far beyond the factory gates. It shaped the exact way families purchased, installed, and lived with their televisions. The machine was not yet a disposable screen. It was an investment permanently tied to the domestic geography that produced it. Because a premium color television in the 1980s was an expensive and heavy piece of furniture, the retail experience was highly localized. A family did not buy a high-end Telefunken, Loewe, or Thomson from a warehouse pallet in a discount hypermarket. They went to a specialist electronics dealer on their local high street. Inside these shops, thick, glossy product catalogs lay on the glass counters. The dealer, who often personally knew the regional distributor, would explain the technical merits of the heavy chassis and the superior lifespan of the local picture tube. When the family finally made a choice, the television required 2 delivery men to safely carry the deep, wooden, or heavy plastic cabinet into the home. Once placed in the corner of the living room, the television dictated the orientation of the furniture. It became the physical hearth of the late 20th century. This deep emotional and cultural connection was cemented during shared national broadcasts. On the evening of July 8, 1990, millions of families across the continent gathered around these locally built screens to watch the FIFA World Cup final, broadcast live from Rome. As West Germany defeated Argentina, The bright saturated colors of the PAL broadcast were rendered on heavy CRT sets built in Nuremberg, Aachen, Angers, and Abbiategrasso. The mechanical click of the power button, the warm static charge building on the front glass, and the rich analog sound filling the room were sensory rituals provided by domestic engineering. When the machine eventually failed, the family did not throw it away. The retail system was completely integrated with a localized repair network. The same neighborhood shop that sold the set would dispatch a technician to the living room. It is here, at the repair bench in the local component supplier, that the true weight of this industrial system becomes clear. Anchor your attention to a deflection yoke winding bench in a mid-sized supplier factory just outside Paris, or the cluttered, schematic-filled counter of a local television repair shop in Bavaria. These physical spaces represented a vast, interconnected web of specialized knowledge. The technician who could safely discharge a 25,000-volt tube and solder a new capacitor, the local women winding miles of copper wire for magnetic coils, and the cabinet makers shaping the veneer, they were all entirely dependent on the domestic manufacturing of heavy glass televisions. If this physical manufacturing plant closed, the country would not simply lose another consumer electronics brand. It would lose the thousands of regional suppliers, the specialized chemical laboratories, the repair knowledge, and the foundational industrial confidence required to build the screen under its own name. By the early 1990s, the European CRT was a perfected object. The screens had become flatter at the edges, the refresh rates had doubled to 100 Hz to eliminate flicker, and the cabinets were masterpieces of industrial design. The industry looked invincible, but beneath this peak performance, the sheer physical weight that had protected these factories was about to become their greatest liability. The television had won the living room, but a small, quiet shift in how the cheapest components were sourced was about to crack the entire foundation. The decline of the European television factory did not begin with locked gates, mass layoffs, or sudden bankruptcies. It began quietly on the secondary shelves of the product catalog, with a change so subtle that most consumers never noticed it. The first small crack appeared in the supply chain for secondary televisions. The smaller 14-inch sets meant for kitchens, guest rooms, and children's bedrooms. By the late 1980s and early 1990s, the massive overhead of operating European glass furnaces and the rising costs of domestic labor made it nearly impossible to build these smaller, budget-friendly sets profitably. Japanese and South Korean manufacturers were achieving global economies of scale that no single European national champion could easily match. To survive this price compression and keep a full range of products in the catalog, European factories began to compromise. They stopped pressing their own glass and winding their own yokes for the smallest sizes. Workers on the assembly lines in France, Germany, and Italy noticed that the picture tubes coming out of the shipping crates no longer carried the stamps of local foundries. They were imported from Asia. The badge on the front of the plastic cabinet still said Thomson, Philips, or Grundig. The manual was still printed in the local language, but inside the case, the chassis was increasingly designed by an external supplier, and the tube was purchased off the shelf. Without realizing it, the European television factory was quietly shifting its identity. It was moving from a manufacturer that created the television from raw materials into an assembly plant that merely screwed together imported parts. This loss of component control was accelerated by a massive shift in retail power. For decades, the specialist high-street electronics dealer had been the primary gateway to the consumer. These dealers understood the engineering inside a Grundig or a Loewe, and they actively sold the reliability of the domestic factory to the customer. But in the 1990s, the retail landscape changed. Massive warehouse-style electronics hypermarkets and big-box chains spread across Europe. These new retailers cared far less about the heritage of the Anger plant or the precision of the Aachen foundries. They cared about inventory turnover, floor space, and aggressive pricing. When a consumer walked into a hypermarket, they were confronted with a wall of dozens of televisions playing the same broadcast. In this environment, the nuanced argument for local engineering was drowned out by the price tag. If an imported set looked identical to a domestically produced set but cost 20% less, the hypermarket pushed the cheaper option. To satisfy the hypermarket's demand for lower prices, European corporate boards executed a series of defensive maneuvers. They attempted to lower labor costs while keeping final assembly within the continent by moving operations eastward. Thomson acquired the massive Polkolor plant in Poland, integrating the skilled Polish workforce into its Western supply chain. Philips, recognizing that keeping heavy glass foundries entirely in-house was becoming dangerously capital-intensive, spun off its CRT division into a joint venture with LG, creating LG Philips Displays. This move legally separated the historic glass foundries from the core corporate brand. In Italy, highly efficient regional manufacturers like Mivar optimized their assembly lines to an extreme degree, squeezing every possible lira out of the production process to stay competitive against the flood of Asian imports. For a brief period in the late 1990s, these defensive strategies appeared to work. The European CRT reached its absolute technological zenith. The factories produced stunning, perfectly flat glass screens with 100 Hz refresh rates that eliminated the analog flicker of the past. The cabinets were sleek, deep, and heavy, filled with powerful subwoofers and advanced digital sound processing. But this late-stage perfection was an illusion. The European television industry was optimizing a technology that was about to hit a physical wall. The factories had doubled down on the massive infrastructure of heat, gravity, and molten glass, entirely unaware that the definition of a television screen was about to change. The heavy CRT had defended the European domestic market because its sheer weight made long-distance shipping unprofitable. But across the ocean, a completely different type of factory was mastering a technology that possessed no such physical limits. A cathode ray tube television pushed deep into the living room because the physics of the vacuum tube required distance behind the glass to fire its electron beams. A liquid crystal display, an LCD, changed the sales floor argument before the picture was even switched on. When flat-panel televisions began to enter the mass market in the early 2000s, the physical barrier that had protected European factories evaporated overnight. An LCD panel was thin and remarkably light. It did not require local assembly to avoid shipping costs. It could be packed by the thousands into standard shipping containers in Asia and distributed anywhere in the world efficiently and cheaply. More critically, the European television factories were fundamentally the wrong kind of buildings. You cannot convert a heavy glass furnace into an LCD foundry. Manufacturing a flat silicon panel requires a multi-billion-dollar, surgically clean fabrication plant, highly advanced semiconductor logistics, and completely different chemical processes. Japanese, South Korean, and Taiwanese companies had spent a decade investing aggressively in these massive cleanroom foundries. European engineers fully understood LCD technology. The failure was not one of scientific knowledge, it was a failure of corporate investment. The boards of the European national champions refused to make the multi-billion-dollar gamble required to build domestic panel foundries, assuming LCDs would remain a premium niche or that they could simply buy the panels from third parties while continuing to control the final television design. They lost control of the most critical, expensive component of the machine. Without control of the panel, the European television was reduced to a generic plastic frame and an outsourced software board. The profit margins collapsed entirely. The historic factories, built to manage heavy glass and win high-voltage copper coils, had nothing left to manufacture. They were reduced to snapping European-designed plastic bezels around imported Asian screens. The collapse of the physical factory brought down the local repair network with it. For 50 years, the neighborhood television technician had been a vital part of the brand's ecosystem. But the flat panel was a tightly bonded, sealed unit. When an LCD failed, a technician could not open the back, consult a schematic, and solder a new resistor onto the board. The entire logic board or the panel itself had to be replaced. Soon the replacement parts became so expensive, and the retail price of a new television fell so rapidly that the product crossed a fatal threshold. It became cheaper to replace the television than to repair it. The local service counters lost their purpose. The industrial unraveling was fast and brutal. In April 2003, Grundig, once the undisputed giant of German consumer electronics, was unable to finance the flat panel transition and filed for insolvency. The great manufacturing lines in Nuremberg were halted and eventually dismantled, sending thousands of workers into a shattered local economy. In late 2004, the Philips Valvo glass furnaces in Aachen were shut down. The intense heat that had pressed millions of screens went cold, effectively ending the physical heart of German component manufacturing. Thomson, realizing it could not win the global flat panel war against companies that actually owned the foundries, orchestrated a massive retreat. In 2004, the historic French champion handed its television manufacturing operations over to a joint venture controlled by the Chinese company TCL. The sprawling Thomson plant in anger was slowly starved of purpose. After attempts to pivot to other electronics failed, the site ultimately closed its doors, bringing an end to decades of French manufacturing ambition. The television industry had structurally separated. The historic company names were highly valuable, but the physical foundries that had built that value were viewed as corporate liabilities. The European television factory did not slowly fade away. It was hollowed out, stripped of its component independence, and finally closed when the math of the flat screen rendered its workers obsolete. The cabinet became thinner, the margins became smaller. The panel came from elsewhere. The factory lost another shift. The furnaces went cold. The dealer changed the display. The repair counter lost its parts. The badge remained. The television behind it had changed. Today, if you walk into the brightly lit aisles of a massive electronics hypermarket in Berlin, Paris, or Warsaw, the history of European television appears to be perfectly intact. You can walk down the row and purchase a brand new flat-panel television bearing the name Grundig. You can buy a sleek, ultra-thin screen stamped with the Thomson logo. You can find high-end displays carrying the Philips badge or budget sets marketed under the historic name of Telefunken. To the casual consumer pushing a shopping cart, the European national champions seem to have survived the technological transition. But this retail display is an industrial illusion. The companies that designed, engineered, and manufactured the heavy cathode ray tubes that define the 20th century no longer exist in those forms. The historic badges survived only through the complex legal mechanism of trademark licensing. When Grundig's manufacturing empire collapsed, the brand name was eventually acquired by the Turkish appliance giant Arçelik, which now produces Grundig-branded electronics in massive, highly automated overseas facilities. The Thomson television badge is utilized by TCL, the Chinese conglomerate that absorbed the French champion's television operations. Philips, recognizing that panel manufacturing was a game it could not win, entirely divested its television manufacturing, handing the brand over to a joint venture called TP Vision, which is controlled by the international monitor manufacturer TPV Technology. Telefunken, once the absolute pinnacle of German broadcast engineering, is heavily licensed by Vestel, another massive Turkish OEM manufacturer that produces millions of generic flat panels for the European market. The name remains. The manufacturer, the designer, the component supplier, and the factory do not. And the historic physical sites, the places that actually built the European 20th century, are gone. The vast Philips Valvo site in Aachen, once a fiery city of glass foundries and high-voltage laboratories, went cold. Much of the site was demolished or repurposed as a commercial technology and business park. The Thomson plant in Angers, which once employed thousands and operated as the beating heart of French consumer electronics, was briefly reimagined as a center for Internet of Things devices before falling into quiet obsolescence and permanent closure in 2012. The massive halls of the Polkoller plant in Piaseczno, Poland, were largely hollowed out, their production lines replaced by the generic logistics warehouses that now distribute the very imported flat screens that destroyed the domestic CRT market. The skilled class of local television repair technicians, the men and women who understood the schematic diagrams, who could safely discharge a 25,000-volt tube, and who kept a single television running for 15 years, have largely retired. Their profession was rendered obsolete by unrepairable, tightly glued silicon panels. Yet the heavy European CRT has not completely vanished from the continent. It has found a highly specific, intense afterlife. In specialized online forums and local collector communities, the late-model CRT televisions produced by Loewe, Grundig, and Philips are actively hunted. They are prized by retro gaming enthusiasts and industrial design collectors. A flat LCD panel is fundamentally incapable of properly displaying the analog signals of older video game consoles. It stretches the image, introduces digital input lag, and ruins the scan lines. The heavy glass CRTs, operating exactly as they were engineered to do, draw the analog image with zero delay and perfect motion clarity. Technicians in these niche communities actively trade surviving service manuals and cannibalize broken sets to keep the last great European chassis alive. There is also a surprising physical footnote to the end of this industrial era. Because the glass of a color cathode ray tube was heavily laced with lead and barium to block dangerous X-ray radiation, it is notoriously difficult and toxic to recycle. Millions of European CRT televisions could not simply be melted down for everyday glass. As the flat panel revolution took over, vast quantities of these heavy leaded tubes had to be carefully buried in specialized, hazardous waste landfills across Europe. The sheer physical weight of the industry remains literally entombed in the ground. This is not nostalgia. It is the permanent disappearance of specialized industrial capability. When Europe lost its television factories, it did not just lose a battle for market share. It lost the deep localized knowledge of how to press heavy glass, win complex magnetic coils, and physically construct a reliable domestic machine. The relationship between a local town, a neighborhood repairman, and the objects sitting inside the family living room was broken forever. The television transformed from a permanent, repairable household investment into a disposable, unrepairable screen. In a small, cluttered retro gaming and vintage electronics workshop on the outskirts of Munich, a massive late 90s Grundig CRT sits heavily on a reinforced desk. The gray plastic cabinet is slightly yellowed from age, and it requires two people to move it safely. When the mechanical power button is pressed, there is a distinct, heavy click. A faint, static charge builds on the thick front glass. A low hum fills the air, and the heavy tube warms into a bright, flawless, instantaneous image. A machine still doing exactly what it was built to do, long after the factory that made it disappeared. See you in the next one.